Hey folks, welcome back. In this lesson, we are going to talk about the close relative of weight conditions, and that is the creation policy. So we can use creation policies from CloudFormation to configure EC2 instances and auto-scaling groups. In the DevOps doctrine, let's go into CloudFormation and then creation policy. And on our left, I have a CloudFormation template, which contains a creation policy. Actually, we're going to split this lesson up into two. So we'll talk a bit about the theory in the first lesson and the template contents. And in the second lesson, we'll dive a little bit deeper into the template contents and then actually create an auto-scaling group with the help of a creation policy. So our main use case is when we're creating EC2 instances, whether by themselves or within an auto-scaling group, and we want to install software on these instances. Let's use Nginx and PHP as examples. Well, we run into timing issues, and CloudFormation could register these instances as created while the software is still being installed. We need a mechanism to pause stack creation until the software is installed on our instances. And that's where creation policies come into play. Now, creation policies work similar to wait conditions. And as I stated in the last lesson, creation policies are the best practice when working with EC2 instances and auto-scaling groups. And like wait conditions, we specify how many success signals need to be returned, as well as a timeout. So to use a creation policy, we associate it with a resource in our stack. So let's take a look at our code here. And note, here's our creation policy, and it is associated with an auto-scaling group that's being created. Min size 3, max size 3 corresponds to our count of 3. We're looking for success from 3 instances. When this auto-scaling group is being built, it will be restricted from going to a create complete status until the creation policy receives its required number of signals. Again, it's very similar to the wait condition. Now, these signals can be sent back to the stack using helper scripts or through the Signal Resource API or CLI calls. And when the stack is building, we will see these signals in the stack. We will also see in the stack the auto-scaling group being built, and then the creation policy will be invoked. Now, a couple other things. This timeout is in ISO 8601 format. It's prefaced with PT. And in this case, our timeout is 15 minutes. And also the default for this count is 1. So if you run into a situation where you don't see a count, then the count is 1. And again, this creation policy is associated within the brackets of our auto-scaling group. So it is only associated with this auto-scaling group, no other resources in the template, although they certainly can be affected. The timing of the creation of everything else is dependent on this creation policy. Okay, so now let's track down our user data. And here is the code for sending a signal back to CloudFormation. And note, it is referencing the stack name. The resource is the web server group. Well, let's remember that is the name given to our auto-scaling group. And very importantly, the region. And we saw that's important when referencing AMIs. Now note, in our user data, we also have CloudFormation init. And this can be used to deploy our application on our instances. So it can read from the template metadata and fetch that metadata. Now in this case, it's referencing the launch configuration as the source for its instructions. Let's go up to our launch configuration and note, install a simple application, HTTPD. There's our index HTML and setting some permissions on the file. So note, this is all contained within our metadata. So again, that is where CFN init can fetch and parse this information and proceed as instructed. So note the order here. After CFN init, CFN signal is retrieving the exit code and sending back to our stack. So it's going to be success or failure. And if for some reason this communication was not working properly, then our timeout will end the stack creation and do a rollback. Not shown in this template, but I wanted to point it out, creation policies and wait conditions can be used together. So the creation policy would be nested inside of the wait condition, and some use cases are track the progress of bootstrapping an instance and coordinate the creation of different resources. An example being, once an action on an instance has completed, then you can trigger the creation of another resource that depended on that action. So I'm going to end this lesson, and then in the next lesson, we will actually create a stack from this template. And key takeaways: wait conditions and creation policies are very similar. They both can pause the creation of a stack until specific resources are provisioned. So just remember the difference between the two, and the difference is that creation policies are the best practice to use for EC2 instances and auto-scaling groups. More common use case for wait conditions would be if you had on-premises resources and you wanted to wait on their creation. That's when you would use a wait condition. So with that, we'll end this lesson, mark this lesson complete, and let's go create a stack from our CloudFormation template, which contains a creation policy.